Hey everyone, welcome back. We're going to be rounding to one significant figure, but this time the numbers are going to include lots of nines, and gradually you'll see why this is important, so the numbers might look a bit different. The answers especially will look slightly different, but it's just important for you to become familiar with how to do this. The strategy we're using for this is actually not going to be any different to what you already know, so it's important that you know about place value and make sure you're going through the playlist video by video so you don't miss any crucial knowledge here. So let's do the first example. So you want to round 97 to one significant figure. So the first thing you want to do is look for the first non-zero digit. So in this case, it's obviously going to be 9. And then the decider is telling you that you need to round up. Now, if the first significant figure, the place value, it's in the tens column, so essentially we're rounding to the nearest 10. So the nearest 10 here is going to be 90, and then it goes to 100, and then it goes to 110, 120, and so on. But in this case, 97 is closer to 100 than it is to 90. So what we can say here, when we're rounding this, is 97 to one significant figure is going to be 100. Obviously, you have to include these zeros because they are important placeholders. You can't ignore them just because it's one significant figure. Obviously, the answer is not going to be 1, it's going to be 100. These zeros are very important. And this is why nines are a bit different when we're rounding. So a second example, 9.7 to one significant figure. The first thing you want to do is look for the first non-zero digit, which is 9. And we know that this is in the ones column. So if the 1 times table, where would 9.7 be closest to? Well, it's a bit closer to 10 rather than 9. So the decider being 7 means that you round that 9 up to a 10. And again, that 0 is really important. Obviously, it doesn't become 1, it's 10. So we want to make sure we have that, that 10 there. So we're not going to say 9.7 is equal to 10. Instead, we have to use correct notation. We're going to use approximates to 10 if we round it to one significant figure. So another example, 0.99. So that 9, the first non-zero digit, is in the tenths column. So that's 0.1s. Now what is this closest to? Well, we know that this is going to be 0.9 on the number line. What do you think goes here? So hopefully you know that's going to just be 1. And this is going to round to 1. So this is going to approximate to just 1. Now, we don't need to write 0.0 here because it doesn't change the number. That 0 is not significant, so we don't need that. We could have put lots and lots of zeros here, but that would have been wrong. And even in an exam, if you put 1.0, that would actually be wrong because that 0 makes it wrong. So one significant figure means just, in this case, it's just going to be 1. Okay, so another example, 996. Have a go with this, pause the video if you need to, and then I'm going to show you how to do it. Okay, so the first significant figure is in the hundreds column. So if you think of the 100 times tables, we're going to round this to the nearest 100. So we know we're going to get 900 here. So it's 800, 900, 1,000, 1,100, and so on. Now in this case, we can see it's going to be approximated to 1,000. And again, these zeros are important, so we don't want to forget to write these zeros here. Okay, next example. This is for you to try. Pause the video. Now there's going to be 1, 2, 3, 4, at least 4 practice questions. It's really important you try this out yourself. This is where students typically will go wrong with this topic. This is very likely to turn up in any types of assessments when they're checking whether how you understand rounding to significant figures. The 9s are the type of questions you can expect. So pause the video for each of these and then I'll show you the answers. I'll do a quick countdown before I show you each answer. So here comes the answer for this one. 3, 2, 1. Okay, so first thing you want to do is, if you like to draw a number line, that's fine. I'm going to do one for this example, but I may not do them for all of them. So the first significant figure here is in the hundreds column, because it's 900. So we're rounding to the nearest 100. So on the number line, we know that the lower part is going to be 900 and the upper part is going to be 1000. And 984 is going to be somewhere around here. And in the middle would be 950, obviously. So in this case, 984 is going to round up to 1000 if we're rounding to one significant figure. So wavy line, so that means approximately equal to 1000. So I hope you got that one right. Here's the next example for you to try. Okay, here comes the answer in 3, 2, 1. So the first non-zero digit is 9, and that's in the tenths column. So in other words, 0.1. You could write 1 over 10 as well. It's the same thing, but 0.1 is going to be better here. So we're rounding to the nearest 0.1. So on a quick sketch, we know that 0.9 and 1 are going to be the 2 bits on each side. And 0.94, now 0.95 will be in the middle. So 0.94, the decider is telling you we don't need to round up because it's 4 or below. So in this case, it's going to round down to 0.9 if it's one significant figure. Okay, next example, have a go. Okay, answers in 3, 2, 1. So the first significant figure is that 9 there, the first 9, which is in the thousands column. So rounding to the nearest 1000. So let's figure out what this might look like on a number line. And you may not need a number line at this point, you might just know this. So there's going to be 9,000. And then it's going to be 10,000 because we're going up in thousands. Now 9,999, well, the decider is telling you to round up. So in this case, it's going to be 10,000. Remember, if the decider is 5, 6, 7, 8, or 9, then it means you're going to round up. Okay, next example. 9,099. Okay, here comes my answer in 3, 2, 1. So the first significant figure is, again, in this case, in the thousands column. So we're rounding to the nearest 1000. So we've got 9,000, 10,000. And on the number line, we know that this is going to be closer to 9,000 than it is to 10,000. Because 9,099 is one less than 9,100. It will be somewhere around here. The other way to look at it is look at the decider. The decider is 0, so we're going to round down. So this is going to be 9,000. Now these 3 zeros at the end are very important. You can't round it to 9, that doesn't make sense. So that's a brief introduction to looking at what happens when we have 9s when we're rounding to significant figures. So have a go at looking at all of these questions here and deciding whether they are true or false. And then I'm going to go through the answers with you. There are 5 questions here. Pause the video if you need more time. Okay, so I'm going to go through the answers now. So the first question, we look at the first significant figure, which is in the hundreds column. So we're rounding to the nearest 100. 599, that's very obvious that it's going to round up to 600. Again, the decider is a 9 there as well. So this is false. It should be 600. True or false? 896 rounds to 1000. So first significant figure is 8, which is in the hundreds column. So in this case, the nearest hundreds either going to be 800 or 900. So we already know that this is not going to be correct. This is false. Now let's have a look at the decider. The decider is 9, so 800 becomes 900. So this is false. Should be 900. Again, I'm going to repeat this topic has lots of silly mistakes by students in terms of rounding, so really make sure you're thinking hard about this. The method hasn't changed. Okay, so 9.5. This is the first significant figure, which is in the ones column. So rounding to the nearest one. So in the 1 times table, so it's going to be either 9 or 10. The decider is 5, so we're going to round up. So it's going to be 10, so this is true. Okay, 0.99. First significant figure is in the tenths column, and the decider is telling you to round up. So to the nearest tenth, 0.9, we're going to have either 0.9 or 1. So in this case, it rounds up, as we said, so this is true. It's going to become 1. 0.09. Okay, first significant figure, first non-zero digit, 0.01. So we're rounding to the nearest 0.01. Now again, this is a common silly mistake. People will put this as their answer. This is not the answer. This is what we're rounding to the nearest. Something in the 0.01 times table. So it should be 0.01, 0.02, 0.03, and so on. Now in this case, 0.09 is closest to either 0.09 or 0.1. And because there's an invisible 0 here, the decider is actually 0. So in this case, we keep it the same. We round. In this case, rounding down is technically the same answer. It's going to be 0.09. So this number does not change. This is false. The correct answer is 0.09. Okay, so I have the answers on the next slide for you, just in case you need to have a look at that. Here are some questions for you to try. You've got all of these. I'm going to show you the answers in a few seconds. So pause the video if you need more time. All right, here come the answers. All right, they're on the right there. Please mark your own work. I hope you did well in that exercise. We are now going to do a fill in the blanks. For this exercise, you are going to work out what the missing digits are. So for example here, these are all the missing digits. And some of these will have more than one answer. So bonus points if you can state every possible digit that works. And I'm going to do the first one for you. So we know that 0. something 6 to one significant figure, all of these are going to be to one significant figure, rounds to 0.4. So if you think about this, if that was a 5 and the decider is a 6, well then that would round up to a 6. So that wouldn't make sense. If it was a 4 and the decider is a 6, then that would round to 0.5. So we know that this the missing digit here has to be a 3. So 0.36 to one significant figure is going to be 0.4. So have a go at filling in the rest, and then I'll show you some answers for this. Pause the video if you need more time. Okay, so I'm going to now go through the answers. So for question B, it rounds to 1,000. So it's going to have to be 9. 985 rounds to 1,000. If it was 885, it would round to 900. Question C, now there's a digit here. Now it rounds to 9,000. So it cannot be 5. It has to be any digit that's 4 or below. So it could be 0, 1, 2, 3, or 4. These are all the possible digits that could go there. That could give you the answer here. I'm going to change the color of my pen because it might be a bit easier to see it. So question D, 0.9. Now if this rounds to 0.9 and the decider is telling you you don't need to round up, well it's just going to have to be a 9 there. There's no other option. If it was 0.84 to one significant figure, that would just stay as 0.8. Okay, next one. E, 0.8. It rounds to 1. This is going to have to be 9 because the decider is telling you to round up. F, 0.87 rounds to 0.09. Now let's have a think here. If it was 987, the decider would make this would make this 1. So this is going to have to be, could it be 8? Well, let's think about this. If that's an 8 and you're rounding to the nearest 0.1, the decider is telling you to round up. So this would be to, that doesn't work either. So what we can try is, this is going to have to be 0, because that would make this the first significant figure, and that then rounds up to 9 because the decider is 7. So there's going to be a 0 here. Question G, this rounds to 2000. So it has to be any digit that's 5 or above. So we can write that as 5, 6, 7, 8, or 9. Can't be anything else. Okay, next one. 0.98. Now it says 0.001 is what it's going to round to. So if we had a 0 here and another 0 here, then 0.001, that's not going to work. So actually in this case we're going to have to get 3 zeros here, and that would mean that this 9 means that previous 0 rounds up to a 1, and that gives you 0.001. So those are your answers. All right, I hope you did well in this. This can get quite tricky towards the end, so just be aware of that. Okay, so that's your fill in the blanks practice. Let's do some final questions here. So here we go. Have a go. Read these questions, and then I'm going to go through the answers with you. All right, 3, 2, 1. Pause the video if you need more time. So 32,461. Rounding this to one significant figure, we know that the first significant figure is the 3, which has a place value of 10,000. So we're rounding to the nearest 10,000, which in this case is going to be 30,000. That's your answer there. Question 2, round the following to one significant figure. 8,600,051. So that's the number written out, 8,600,051. We're rounding to one significant figure, so the first digit here is in the millions column, so 1 followed by 6 zeros. So rounding to the nearest million, 8,600,000 is closer to 9 million than 8 million. So this is going to be 9 followed by 1, 2, 3, 4, 5, 6. 6 zeros there. So we're rounding to the nearest 1,000. Right, next one. We are going to be rounding the product of 19 and 351. So you can just use a calculator for that. So it's going to give you 6, 6, 6, 9. We're going to round to one significant figure. The first non-zero digit is that 6, which is to the nearest 1,000. So we're rounding this number to the nearest 1,000. The decider is another 6, so that 6 is going to, the first 6 is going to round up to 7,000. And that's your answer there. Right, the population of Frome is 90,000 rounded to one significant figure. What's the lowest number it could be, and what's the highest number the original number could be? So 90,000 to one significant figure means that it's been rounded to the nearest 10,000. So this is where a number line might be a bit more helpful here. So to the nearest 1,000, if we know that our answer is 90,000, let's have a look on either side. So it could be 80,000 on the other side and 100,000 on this side here. Now there's going to be somewhere on the number line where we round down to 90,000 and somewhere where we have to round up, and we have to find out where that point is. What number would that be? So in this case, it's going to be halfway. So 80,500 is not going to work. Sorry, that should say 85,000, not 80,500. That's my mistake there. Right, so it's going to be 85,000. And on this side, it's going to be 95,000. So the reason you would round up here is because the decider is a 5. And we want that number to be as small as possible, but the smallest one where you have to round up. So that has to be a 5. And in this case, we want the smallest number that rounds down. So 95,000 will actually round up to 100,000 if you're rounding to one significant figure. So it's going to be one less than that. So it's going to be 94,000 999. So let's just have a check here. 94,999. So the first significant figure is 9, which is in the 10,000s column. And the decider is telling you not to round up. So the nearest 10,000 is going to be 90,000. Those 9s at the end don't make a difference here. So the answer here will be 85,000 and 94,999. Okay, so I'll see you in the next video looking at rounding to two significant figures and then rounding with 9s to two significant figures, and then that should be enough to get you through this whole topic and the rest of the topic. If you need to round to any other numbers, you'll be fine with that. Okay, smash a like button, hit subscribe. I'll see you in the next video.